Good evening, fellow Earthlings, and welcome all of our esteemed Milky Way residents to our kind of semi-annual Desert Skies Star Party. Good evening, fellow Earthlings, and welcome all of our esteemed Milky Way residents to our kind of semi-annual Desert Skies Star Party. All right, slight issue there, so I had to get everything off the computer. So we're back live again now. So yeah, we're gonna have some fun exploring our local universe. If you can, please ask any questions if you want to in the chat, and if you want to let us know where you're observing from, that would be great. Just let us know, city, state, or country. About halfway through the event tonight, we are going to, we'll pause the object slightly and let our astronomers show you what equipment they're using, so that if you want to get a better feel for that or ask any questions about that, you can. So I am Jim Knoll. I will be moderating tonight. And on the scopes, we have Bernie Stinger and Jim O'Connor. So I'm going to just ask Bernie or Jim, either one of you guys, are you ready to go right now? If not, I will take a look at where we're going to be looking at.
I'm good.
All right, Jim, then why don't you go ahead and share and start us off?
Okie dokie. Love this high tech.
Jim, I'm not seeing your screen.
It should in a minute.
Oh, there it is. Okay.
Sorry about that. It was giving me you as a screen. So. Okay. This little object I decided to start the night off with is one of the few things that looks almost like its name. This is called the owl cluster, sometimes called dragonfly and sometimes called Kachina doll. And finally, some people call it ET. It should look like the two bright dots you see in the upper left part are his eyes, and down below a little bit, it's his wings outspread, and way down at the lower right are two stars that make up his feet. Well, that object was discovered, about 1787, and it's about 8,000 light years away from here. Its estimated age is 21 million years. And right now I'll stop and say this kind of an object is an open cluster. These stars are formed at the same time out of a big gas cloud, and they usually have close to the same ages of the stars. We're looking at this object when it's about an estimated 21 million years old. Usually they'll stay together for under 50 million years. But the dynamics of the universe, as it's twisting around, that each of the stars starts moving away at its own rate, and so we're lucky to see it right now, looking back at us. It's in the constellation Cassiopeia, and there's an estimated 150 stars there, not very many, and the eyes that you see in the upper left corner, there's something interesting about those. Those aren't part of the cluster, really. They're in that when you draw that big map of the sky, they're called part of the cluster, but they're only about half the distance to it. They're about 4,000 light years away, when that cluster itself is the rest of those stars you see are about 8,000, a little more than 8,000 light years away. But it looks so attractive, like it belongs there, That's for 300 years. Astronomers have been calling it the owl because of those eyes. The It's one of the first things I could get up tonight. It was kind of interesting, and it was very nice and dark background. And it's sunny out here. I know some of you may be on another coast, and it might be pretty dark, but right here the sun just went behind the hills. And well, that's about what I can say about the owl. I will say one more thing about it. I was at a set up with my telescope at a Boy Scout camporee once, and it was on an Air Force base. And the the young the younger Boy Scouts all looked in and thought they called it an F-15. So I have to keep that name in mind of what some people think it looks like. But that's the owl cluster, and it's in Cassiopeia.
I guess it can be whatever you want it to look like, huh?
That's right. It's like clouds in the sky. You name what you see, and it goes away.
That's right. So real quickly, I'm going to show you where in the night sky that is. So this is a program called Stellarium. It's a free program. You can download it, put it on your PC or your tablet. So we are looking towards the northwest. As Jim mentioned, it's in the constellation of Cassiopeia. It's right, you can see it fluctuating right here, but it's right by Cassiopeia's knee. So when you look up in the sky, you see the familiar M or W, depending upon which way it is. There's a sharp triangle and then a shallow one, and it's right off the shallow point of it. All right, Bernie, you ready?
Yeah, I think so.
All right.
Well, we'll certainly give it a try here.
Okay, you got it.
All righty. Tonight, I was planning on showing you Venus to start out with, because everybody loves planets. So, let's start broadcast. I got to get over to the program here. Okay. Okay, what you're seeing right now is, for some reason, and I'm not sure exactly why, but what I'm getting is a double image of the surface of Venus. Now, I'm not sure exactly why. It could have something to do with it being close to the horizon or just being as bright as it is in the sky. But I'm sure everyone has seen that bright star to the west after sundown, and of course that's not a star. That's the planet Venus. And right now it is in a phase angle of around 25 to 30 degrees. Um, the the planet Venus, like the moon, goes through phases. So there's times when it's full. There's times when it's just a small arc. There's times when it's a quarter. And right now it's in that small arc phase. And that's because it's coming around the sun and it's getting close to the point where it's in between us and the sun. So we don't see a whole lot of sunlight being reflected off of it because the side that is receiving the sunlight, most of the sunlight is the other side of Venus. So we're looking at kind of the backside of it with a little light coming around the side of it. And that arc will get tighter and tighter and smaller until it actually gets right in between us and the sun. And that's called superior conjunction when it's in between us. And right now, The planet is 35 million miles away. So it's fairly close in its orbit to us. And that will continue to increase until it reaches superior conjunction. Um, I'm not exactly sure when that's going to happen, but it's probably within the next month or two. The planet Venus is totally cloud covered. So visually looking at the planet, all you see is a white disk. In photographs, using an ultraviolet filter, you can discern a little bit of varying cloud cover, but there is no way to see the surface. The cloud cover is far too dense and too thick. So the only surface images that have ever been taken were back in the 1980s, I believe, or it might have been earlier than that, by the Venera spacecraft that were sent there by Russia. And those spacecraft landed on the surface and lasted long enough to take some pictures and a few readings of the surface and radio it back to the Earth before the, the crushing pressure and temperature on the surface of Venus just destroyed the spacecraft. And it measured temperatures of well over 800 degrees Fahrenheit and high enough to melt lead, and also pressures far beyond anything that humans could endure, obviously. So our thoughts of ever visiting that surface are probably never going to happen, nor would we want to. There's really no point. So that's the planet Venus. I wish I had a slightly better image of it, but it is what it is. So
It almost looks like it might be a little out of focus, Bernie. You can maybe check that for your next one or something and see if you.
I ran it through a couple of focus runs, and it didn't seem to make a difference. So
Interesting.
um,
Okay.
I'm yeah, you're right. It does kind of look like a focus issue, but I don't think it is. I guess my next object will prove that out one way or the other.
There you go. Yeah, so let me just, I'm gonna grab the screen and I will show everybody where that is in the night sky. So as Bernie mentioned, it's that bright object to the west. You can see it right here. It's kind of hanging out in Pisces. Um, and it's usually very, very bright. I believe, Bernie, it goes to superior or inferior conjunction on March 27th. So we got about another month. So if you were to go out, say at the same time each night or over a week, every once a week or at the same time, you should start seeing Venus getting lower and lower in the night sky as it gets closer and closer to coming in between us and the sun. And then when it does go in between us and the sun, it'll basically set when the sun sets, and then it'll pop out the other side, and typically then it's in a morning object. So, we always refer to Venus as the morning star or the evening star because it never really varies too far from the sun, even though it's not a star, but we kind of call it that because it is very, very bright.
Did I get my inferior and superior backwards?
Well, I could have it backwards too. I don't know. I
You
think
know what? You know what? I thought superior was when it was on our side, and inferior was on when it was on the far side. Jim, what do you think on that?
Sounds good to me. But no,
Okay,
I think you
obviously
only have,
us
I think you
astronomers
only
are going to
have
have to
those.
figure that one out. All right.
I think you only have those when you're talking about the outer planets. Inner planets, it's a different way of talking about them, and I don't know.
Mm.
We'll look it up.
Yeah, we'll check it out. Or if anybody wants to knows that's on the chat, let us know.
There you go. That's
All right,
another
Tim,
way.
are you ready?
Yeah, I'll give it a shot.
All right, you're up.
Let me share something here. Yeah, I think I pushed all the right buttons. Should be up there.
Yeah, we see it.
Okay, this beautiful little object, it's actually a really large object, is the Great Nebula in Orion. It's in the constellation Orion, as its name is, but what it is, it's the biggest star-forming region nearest the Earth. When we see the four bright stars at the center there, that's just what's making everything shine. In the background and covered up by somewhat by the clouds of gas around it are close to 1,500 other stars. And if you go outside the frame that I'm showing, there's close to 2,500 stars in a single cluster. That's called the Orion cluster. And but what we see right now with our advantage is four very, very bright stars. They're the brightest stars in a group called the trapezium. There are about, with a good telescope, you can see up to about 7 stars in that area, but several of those four that you're seeing are double stars. But they're so bright that they swamp each other's light out, and you just see one bubble where we're looking at my magnification. That color around it, you'll notice it's got a lot of different shadings to it, like a curtain that's been sort of left in the storage closet a little bit too long and hasn't gotten straightened out yet. The reason is that these are late generation stars, real recently, within a galactic kind of sense of time. If they're only, they're probably less than 10 million years old. And the reason that those clouds are so interesting configured and colored is there have been a lot of supernovas in that area in the past. So you have not only hydrogen floating around out there, you've got other gases. And plus you have so many stars we can't see that where we see the bluish tints along the bottom ridge, and you can actually get yellowish if you have a silicon or a sulfur filter from the supernovas. When it gets bluish, it's reflecting light. It's far enough away from the bright stars that it's only reflecting. It's not being lit up like a neon sign by the inner stars. So that is about the whole nebula. I'm going to press a few more buttons here, and we're going to see the actual size of it. That nebula itself is about 20 light years across. It's about a light year and a half away, so it's fairly close. And I'm sorry, 1,300 light years away. I knew that was a little bad. 1,300 light years away, and as I said, it's the closest region of massive star formation to the Earth. Let me try to see it in a different intensity. I'm going to look at it. Right now, my image is only being captured for about 1.2 seconds. So what I'm going to do is change it and open it up to maybe double, about 3. And let's see what we get there, 3 or 4. So if you count up to about 4 seconds, if you can see my screen on your screen, oh, that's a little better. Notice all of a sudden it's grown, but now you can see the reason I wanted to show that inner part that's causing all the light. The very, very bright stars that get whited out when you try to show the full expanse. And if you look up at the top of the screen, you'll see a white star up there with very faint gas around it. That's part of the same nebula. As I said, it goes well off the margins of my screen. So that's only 5 seconds. And I'll take the final picture here of it. And I'm going to up it up a bit. I'm going to go up to about 15 seconds and see what we can get. And that means I have to wait 15 seconds. If you see a sliding gray bar on the bottom, that's the timing. Till it gets to the far right, it's ready. You can see there's no end, almost no end to that thing. It is a giant nebula. Now, just like the owl, you can call that anything you want. I think it looks like a piranha sometimes. I know other people have different points of view, but you can see how much energy is coming out of that thing because it's swamping my instruments at such a short time, only about 15 seconds. But I like the colors. And next time it's my turn, I'm going to jump to something that's right above that white star, and it'll look quite a bit different. So I'll just let you wait for that. And yeah, I think I told all the damage I can about that one.
Yeah, well, that's kind of cool to be able to see. A lot of times when you look at images of the of Orion's nebula, you just see you can't see the trapezium because it's just so bright. And those four stars, the baby stars in there that Jim mentioned, we're able to see the nebula because they are lighting it up from within. If the stars had not started forming yet in this region, then we wouldn't see anything. It would be what we would call a dark nebula. You wouldn't see any stars because the gas and the dust would blot out any background stars, but we wouldn't be able to see the beautiful nebula. And so we rely on the stars from within it to light it up. So yeah, as Jim mentioned, this is one of the closer star forming regions. So this hydrogen, this gas cloud will probably make hundreds of stars. And it's pretty good size, 20 light years across. Now, in context, the nearest star to us is in the Alpha Centauri system. It's called Proxima Centauri, and it's 4.2 light years away. So you can imagine when stars are born in a nebula like this, they're going to be very, very close together. And then when they use up the gas, they become what we call an open cluster, and we'll look at some of those tonight as well. And they will travel around the Milky Way galaxy for a little while as an open cluster before they start drifting apart, and those are basically made up of young stars as well. All right, and let me show you. If you're done, Jim, I'm going to show them where.
What I was going to do is throw in one more thing. The reason those four stars are so bright that they're each from 40 to 400 times as massive as our sun. So they're giants. They're very big, and they're not going to live long. Another 20 to 30 million years, they're probably going to go supernova.
Yep, they live fast and die young. All right, so this is where we're looking in the night sky. So again, we're looking right now, it's kind of off to the southeast. This is the constellation of Orion. Typically, you can make out Betelgeuse, which is a very colorful red supergiant. Looks kind of orangey, his right shoulder. And then over here is his left shoulder. And then down where his knees and feet are, the other one that's pretty prominent, you got Betelgeuse, and then down here you've got Rigel, which is a blue supergiant. And then his belt right across the middle, which is pretty easy to find. And then if you look carefully down under his belt, this is called the sword. And this would be where his sword would be hanging, which you can see the sword right there. And what we're looking at, the outer ones are stars, but the inner one is all the stuff that Jim was showing you. That's the nebula. And so, yeah, that's in the constellation Orion. All right, Bernie, you ready? Maybe?
Yep.
Okay.
You got to give me a minute. I've got a number of screens. I got to go back and forth.
It's okay.
Yes, I'm ready. Thank you.
Okay, you got it.
All right. Let me share my screen, start broadcast. Oh. And as soon as it connects, come on. There we go. There it connected. All right. So what I've moved over to now is, as you can see on the screen here, it's called the Triangulum Galaxy. This is one of my favorite showpieces when I do star parties out in public venues, especially this time of year. It's a wonderful kind of fall winter object, and it's easily found in the night sky. It's called the Triangulum Galaxy. The Triangulum Galaxy is not named after anything that is a triangle. It's in the constellation of Triangulum. So that's why it's called the Triangulum Galaxy, because of the constellation it's located in. This galaxy is about 3 million light years away. So it's just a little bit further than our closest neighbor galaxy, which is the Andromeda Galaxy. The Andromeda Galaxy is 2.5 million light years away. So this one being 3, it's a little bit further away, but it's still part of what we call the local group. The local group is a group of about 10 to a dozen galaxies that travel through the universe together. They're gravitationally bound, so they all travel together as family unit. And it's called the local group. So this is one of our cousins, if you will, the Triangulum Galaxy. It's a little smaller than our Milky Way galaxy. It's about 60,000 light years across. So from the left side to the right side of that big white cloud there, that's about 60,000 light years. Now, what is a galaxy? What is that white cloud? That is stars, billions of stars. And those stars are all gravitationally bound together to form that galaxy. Now, that galaxy, those stars there's so many of them, they blend together and just look like a white cloud to us. And the reason for that is because it's so far away. We can't see the individual stars. It's just too distant. So all those stars blend together into what looks like a white cloud, kind of like what the Milky Way looks like when you look up at it in the night sky. If you've seen the Milky Way, you know it looks like a white band. Well, that white band is billions of stars. And if you aim a telescope at the Milky Way, you'll see it's just a whole image full of thousands and thousands and thousands of stars. The center is a little bit brighter because there are more stars in the center core. And of course, M33, like almost all large spiral galaxies, has a black hole at the center. Now, I can't show you the black hole, so don't ask me to find it. It's you can't see a black hole anyway. This is a face-on spiral galaxy. And I want to point that out because I'm going to show you a different type of galaxy next. There's about 40 billion stars in this galaxy. Now, I'm not sure who stayed up all night and counted them all, but I want to give that guy an award. Around the galaxy, you'll see individual stars, some further out, some closer in. Those are not stars. The dots that you see around it are not stars in that galaxy. Those are stars in our galaxy. To see a distant galaxy, you have to look through our galaxy first. So all those individual ones that you see kind of sprayed around, those are stars in our galaxy. They're like the forest right in our face. whereas that galaxy is much, much, much further away. If you could take away those stars in our galaxy, you would see blackness all the way to that galaxy, 3 million light years away. It was originally discovered by an Italian astronomer back in 1654. Now, that discovery age is very early on. Most galaxies were not discovered until the mid to late 1700s. So for one to be found at the 1600s is rather unusual. And the main reason for that is because of its brightness. This is one of the two brightest galaxies, the Andromeda and this one, in the night sky. And some people say that on a very dark night, they can actually spot M33. I've never been able to do it, but perhaps some young eyes might be able to pull it off. So just some interesting facts on M33, the Triangulum Galaxy.
All right. Thanks, Bernie. Yeah, you're right. I mean, that is a beautiful galaxy to look at. It's just nice and straight on and really easy to be able to see, and you can see the spiral structure to it and the shadings and things like that. So yeah, it's a great one to look at.
I think there's 5 or 6 distinct arms there that I could see. 1, 2, 3, 4. Yeah, I see 5.
Yeah, so I don't know if they think this is kind of what our Milky Way probably looks like, from face on from a distance.
Well, I think the Milky Way is a barred spiral now.
That's true. That's
They've
true.
decided it's a barred. And
Yeah,
this isn't a barred spiral, but otherwise, yes,
yeah,
probably would look very similar to this.
yeah, yeah. So what Bernie's talking about is right in the center where you see the kind of the bright area. For the Milky Way, we have a bar of the core basically that's really the center, and then at the ends of the two bars are where the two main arms of the Milky Way galaxy come off. All right, I'm going to take the screen and I'll show everybody where that's at. So we are looking, let's see, oops. I went back to that. All right, hang on a second. I got to get over to 33. Well, I guess it's didn't have to move very far from Venus. So anyway, um, Bernie mentioned it's the Triangulum Galaxy. So here's the constellation of Triangulum. It's just, 3 stars that are kind of in a triangle. It's if you were to look at Cassiopeia, which is the W we looked at earlier, and then go to its left or south, you're going to come across Andromeda. The steep point of Cassiopeia kind of points right towards the Andromeda galaxy and the Andromeda constellation. And then if you go just a little bit beyond that, you find the Triangulum. So it's kind of out in the middle, empty space. But, the constellations, although they show pretty pictures here and line diagrams, they're actually, they're regions of space that, that are going to be kind of like a map of a state. They're going to have more than what you're going to see here when you look at them. And so constellations are kind of our map in the night sky. So, the first thing we want to do if we're trying to figure out what we want to look at or where we want to look is we want to figure out what constellation it's in. And then you determine if that constellation is visible and how far up it is, because we don't like to look at stuff low on the horizon because, then, we're looking through the heaviest part of the Earth's atmosphere, especially when you're down, down low, even, 3,000 or 4,000 feet, you're still looking through the heaviest parts. You want to look as high as possible, almost straight up is ideal, to be able to get above the atmosphere as quickly as possible so that, because the atmosphere is what blurs everything. So like when you look at planets or stars or anything really close to the horizon through a telescope, you're not going to get a good view at all. You want to look high. And then the professional telescopes, not only are they big, but they also are set up on high mountains, most of them between 10 and 15,000 feet. Well, if you get up to 15,000 feet, you're above probably 90% of the atmosphere. And so you very quickly get out of that blurring area. And so that's why they're up high on mountaintops. But for us amateurs, we're stuck where we are. Tucson's about 2,500 feet, so we're looking through quite a bit of atmosphere. But anyway, so that's triangular, and this is looking towards the west. Jim, before you share your screen, I am going to show them what equipment you're using if you want to chat about that a little bit. So this is what Jim is using. So go ahead and tell them a little bit about your equipment.
The conglomeration of equipment you've got there is set up so I can do either solar during the day, which is the white scope on the right side, or deep sky on all the other pretty things that's a big blue thing. My laptop that I run the whole show is there on that little brown travel table, and in its protective bag or its coat, there's a monitor that's that I use when I go into public places and show it. I still use it when I'm here because I can see, there's some things I can see in it because it's pretty big that I can't see that I can see detail, so I can make sure I'm getting things right. The telescope is a Meade LX5 10-inch. That means it's 10 inches in diameter across the front. It normally starts out as what's called F10. That means the focal length is 100 inches. But mine is only at 5 and 5, LX5. I mean, focal length 5, focal ratio 5. I'll get to it yet, F/5. Okay, the reason I do that is so that the image shrinks and it makes the colors and the objects and the light in a smaller area. And it's easier for very faint things to be imaged in a shorter time. That's why the lower the F number, the faster the instrument you've got. And the same thing with cameras. Lower F number, you get the picture faster because the light gets gathered faster. The other thing that's kind of rough with a telescope that big to use a camera on is the objects are big. And the next object I talk about, I'll try to point out why even at F5, I got a pretty big, it fills up a good chunk of my 24-inch screen and also my 17-inch laptop. Up on the top of the telescope, there's two little things. The thing that's closest to me, that thing that Jim's pointing at right now, is a finder scope. It's got a little bullseye it puts on. You look into the inside of the box, and there'll be a bullseye pointing exactly where you're looking at the sky. So if you try to find something and you're not using computer-aided equipment, that thing points out where it is and how you can find it. Opposite to it, around the arc a little bit, is a tiny little camera. That does all the work of setting the telescope up. When I get ready and it's dark enough out there, I just say, star sensed. That's the name of the camera. It'll steer the telescope itself around to 4 different parts of the sky and get 100 to 100 stars in each little circle of the sky it's looking at. And it matches that to a map it's got internally of what the stars are. And it's called plate solving. And it does that 4 times in 3 minutes. So it's really quick when it moves around the sky, and it would take me about 15 minutes to do just 1 star in all those places. So I really like it. It helps me get through the observing. The mount it's on is Celestron Advanced VX or AVX, and that works in, it's a German equatorial mount, and that means it follows the rotation of the Earth. So if I align it perfectly, I only have to move it in one direction, follow the circle. And for astrophotography too, it's got good behavior. Lets me put a lot of weight on it. That right there, you're saying is 32 pounds of telescopes and 30 pounds of weights are on it, and it does very good for the price. And so that's what I'm using to bring in a lot of magic.
You want to talk about the camera at all?
Oh, the camera. Yeah, the camera. And I also have notes written about it, but I didn't, they're not visible at night, surprisingly. Okay, the camera on the back, that round, big tomato pan on the back, is called a Meade's sky radar. DS means dark sky. 10, which means it's got 10 megapixels. C for its color. TEC, thermoelectric cooler. All those letters just say it's really good at going things very dim. It's got 10 megapixels and its color, so it puts out some very nice results and very, very fine resolution. And it's cool because video chips get hot when they're working. There's a lot of electricity passing through those things, and the friction of the electricity inside the wafers, the chips, makes it really warm. Right now, I'm operating at freezing, at 0 degrees centigrade, 32 degrees Fahrenheit in that, even though I'm about 55, 60 degrees where I'm sitting right now. It's very handy. Otherwise, you can actually damage chips if you use them too much at the higher temperatures because they got layers of different kinds of material stacked up, and they expand and contract at different temperatures, at different rates during temperature changes. So they eventually can delaminate. They can come apart like the pages of a well-used book and start shredding. So the cooler stops that from happening. So that's what I'm bringing you the pictures on, and I think it does pretty good.
All right, excellent. So let's see your object.
My object. Oh, what did I ask? What did I recruit to bring in here? Let me go share it. And why not this one? And there. And you can let me know if you see anything, Jim.
Yep, we got it.
Okay, that massive cloud on there and the dark shadow in between it, if you look kind of, if you've got good vision or if your set's okay and I didn't screw up the signal coming out, it's called the running man. It looks like Superman with a cape back there running across the sky. That is, if you remember the size of the picture I had of the Orion Nebula, that is about 1.5 more screens to the side where the piranha's mouth is. It's called the running man. And now something you'll not miss is when Jim comes back to narrate, you'll see it in his left or your right corner. I mean, the upper corner are the bright 3 stars across the bottom. It just happened to be in that application he's using. Okay, the running man itself, that's got a lot of gas sitting there. And perhaps I can see it. What's I'm doing here? It's called New General Catalog, NGC 1977. It's a reflection nebula. See how, if you see a tint to it, mostly it'll be yellow or bluish. The brightness of the stars is what's being reflected, and the gases tend to reflect the blue, the shortest wavelength, better. So that's a reflection nebula. It's not an emission nebula. If you saw how bright everything was around the Orion Nebula, because emission nebulas are so close to the bright stars that they get, the stars put out a lot of radiation. That radiation turns the cloud around it into a neon sign. That's not happening here. The light you're seeing is reflecting the light of those stars. So it's a reflection nebula. It's in Orion, real close to the Orion Nebula, and it's ionized, or it's reflecting light embedded. And in the constellation Orion, this region is it's a whole region of ionization called a H2 region. That's where the hydrogen is getting lit up. Sometimes it turns blue, and sometimes it turns red. It's blue from reflecting, red when it's actually activated. And it looks like that's a little more red in there than I thought there was. It includes this, the nebula itself includes this one, Running Man. The Running Man is actually a dark nebula part of the Running Man Nebula. It's kind of interesting. They really got 2 different numbers. It's a northernmost part of the Orion's sword. It's about half a degree north of the center of the Orion Nebula. It's 20 light years wide, and it's 3 times of the distance from the Orion Nebula to that little nebula that was on the top of my picture. 3 times more, or 4 times total. That's where the the Running Man sits. It's a fascinating thing if you got enough instrument to really go get it. And I congratulate myself because that's the latest nice, pretty thing in the sky I found.
Yeah, that's a really, really good picture, and you can definitely see the dark outline of a figure of a running man.
The thing that fascinates me is the fact of what the speed of when I said my telescope was f5. If I was using it as at its normal capability of f10, it'd be twice as tall. I couldn't. I would have to show it in pieces if I wanted to. But at f5, I can fit it into the monitor to the full video frame size.
Yeah, it's framed perfectly. All right.
Yeah, I think you got lucky on the camera angle there, Jim.
Well, yeah, it's a round camera. You don't always know how you're setting it up.
Exactly. Yeah, exactly. You just lucked out perfectly.
You could
But
have
I
been.
use the brass from the cooler, the little screw on it from the argon chamber. I always have that up. That way I know where up, down, and left, right are.
And there you go. There you go.
Yeah,
You know, what I like to do is tell people to think about Gumby, the old Gumby figures. Um, so
Yeah,
there are those of us old enough to remember Gumby
and Pokey.
and Pokey. Yep, there you go.
very cool. All right, well, let me show everybody where that is in the night sky. So we'll go back to Stellarium. So now we're looking south again. We're looking towards Orion, which you can see right here. And there's the belt. And then earlier, this is the sword down here. And if
We're
I,
right at the top of the sword.
yeah, if I zoom in, so here's the nebula, here's the bottom star, and here's the top stars. And that's the running man.
The top three stars are part of the Running Man.
Yeah, so it's right next to Orion's nebula. Okay, very good. Bernie, over to you.
Okay. Back online. Let me start a share here. Very good. All right. So the last object that I showed you was a galaxy face on. Now, galaxies are shaped like great big dinner plates. They're large if you have them face on, but they're very thin and narrow if you hold them edge on. So when I show a face on galaxy, it helps to show an edge on galaxy for comparison. So this is an edge on galaxy. It's called NGC 0891. It is in the constellation Andromeda. And let me see if I can bring that out a little clearer for you. It's quite a bit further away than M33, so I need to zoom in on it. So a little bit of zoom and a little bit of magic. And there it is. That is an edge-on galaxy. That's a spiral galaxy as well, just like M33 we looked at previously. However, in this case, we're looking at it down its edge. So again, all the little stars sprinkled around, those are stars in our galaxy. The galaxy itself is the fuzzy white section in the middle. This galaxy is also called the Outer Limits Galaxy. It's another one of its given names. The reason for that, those of you who may remember back many, many years ago to the old science fiction series on TV called Outer Limits. Right at the end of the program, they'd be showing the credits, and during the credits, they'd be showing pictures of galaxies. And this was one of the galaxies that they showed at the end of the Outer Limits. So that's why it picked up the nickname of the Outer Limits galaxy. Now, the galaxy I showed you earlier, M33, was 3 million light years away. NGC 0891 is 30 million light years away. So it's 10 times more distant than the M33 was. And that's one of the reasons why I had to zoom in on it to present it more clearly. This galaxy was discovered by Sir William Herschel, a very famous astronomer, English astronomer, back in the 1700s. And he discovered this in 1784. He was lucky enough to have some superior telescopic instruments to be able to gaze into the night sky and look for fainter, smaller objects. And of course, he didn't know what it was. He just cataloged it as a nebula. Back then, they called them nebulas, being a nebulous object. They didn't know what it was. It wasn't a star. They couldn't resolve it into anything. So it was just thrown into a big hat called nebulas. Wasn't until actually the middle of the last century when nebulas and galaxies were actually differentiated. And that was due to the power of very, very large telescopes. So this is one of my favorites. I love to show this one at star parties. And one of the things you can see on it is kind of a dark band that splits it in two from top to bottom. There's a dust lane, if you will, right on the very extreme of the galaxy, and that's what's causing that blackness. It's just absorbing and blocking the light from the center of the galaxy. And again, the middle of it, you'll notice, is brighter there, and that's because the center of galaxies are have more stars, gravitationally have more stars than um, the outer spiral arms do. So part of the reasoning there. Jimmy, got anything to add?
No, it's very cool. It's that's a beautiful edge on Galaxy. You can see the central bulge a little bit. It's a little bit thicker right in the middle where the core is, like Bernie mentioned, and that's a gorgeous dust lane. Yeah, I don't know that I've looked at this one very often. I'll have to add that to my list. It's a cool object.
There's 3 or 4 very nice edge on galaxies that I like to use and show at star parties. And the nice thing about them is they are spread out in the sky about every 90 degrees or so.
Mm.
So there's one in the summer, one in the fall, or one in the spring, and one in the winter skies. So you've always got one to show.
Yeah.
That's what I like about them. NGC 4565, I think, is one of my other favorites.
All right. Very good. Yeah, and before I show you where that is in the night sky, Bernie, I'm going to share your equipment if you want to chat a little bit about that.
Oh, sure.
Let me bring it up. Let's see. There it is.
Okay. Well, this is a picture I just took about an hour ago of my scope set up here in my driveway, right outside my home. This is a Unistellar. It's a company. Actually, it's not an EV2. But that's fine. It's my latest acquisition. This is a Unistellar Odyssey, which is their latest scope that they've just come out with in the last 3 or 4 months. So the nice thing about this one is it's very small, it's very light, and it's extremely portable, which makes it excellent for taking to star parties because I can toss the tripod out, level it, pop the scope on top, push the on button, and be looking at objects and showing the public within, 10 minutes, 10 to 15 minutes easily. And takedown is equally as easy. So it's perfect for using it out in public venues. So that's the Unistellar Odyssey.
Very cool. All right. Let me switch shares over and I'll show you where Bernie's last object was in the night sky while he starts getting the next one up. So this Edge-on Galaxy, like he said, was in the constellation of Andromeda. So it's kind of right at her feet. So Andromeda right now is upside down. So again, here's Cassiopeia over here. So now the shallower triangle is kind of pointing towards this object, and it's right at the edge, probably right at the edge between Andromeda and Perseus. All right, Jim, you ready?
I think I'll give it a shot.
All right. Did I see it?
Got it. Okay. Um, that object is called Messier number 82 in the Ursa Major, right off the bowl of the Big Dipper. And it's got a name called the Cigar Galaxy. And there's a lot of features about this galaxy that make it interesting. One of which is you'll notice if you look at it looks like oatmeal with a lot of white globs floating around in it. Well, that's because it's called a starburst galaxy. Stars are being generated quite a bit all over the place in there, and to get the real facts about it, it's about 12 million light years away, so it's really close, which is kind of nice because it's easier to pick it up. And uh, I had had a flashlight that died. Um, it's got recently deeper, more higher resolution images of that galaxy found spiral arms in it, which were kind of unusual because it looked almost like an elliptical galaxy, a galaxy that's sort of looks like a long cigar, and it's usually the result of multiple galaxies kind of merging together. This one, though, still does have some spiral arms. A few of the facts I like to point out is those bright lights. There are over 200 clusters of stars in there that have over 200,000 new stars each. That's what's making that bright light. You might see a dark diagonal band coming down through the middle of there. That's separating two merged galaxies. There are actually two supermassive black holes in that galaxy that are stirring things up after the merger, and that's what causes the gases that have been floating around in that galaxy that actually causes them to get hot and start forming stars on their own. And if you look at the cloudiness on the two ends, the two extremes, the upper right, lower left, those are billions of stars in those areas, except they're more separated than all the stars in the center bubbles that are floating around in there. This thing is, it's very interesting, but I wouldn't like to be close to it because with all kinds of new star formation like that, especially of large size, you're going to have an awful lot of radiation that doesn't support life as we know it. So I don't think you're going to find a whole lot of traveling species that want to be introduced to us coming out of that one. It's really a dangerous place to be for life. Um, what's I have to say here? Oh, I think the thing I used to like most about finding this, and I can make it bigger sometimes and really get into the makeup of it, is just that there's so doggone many stars there. Uh, with the number of, we're talking uh, many billions of stars, many billions of stars that are, and most of them are relatively new. That's what's fascinating about it. That the action that's going on around there, and right off the edge of the screen, and I can't move the scope enough to let you see it and see this too. There's another galaxy, a bigger one, a big spiral sitting there called M81 Bode's galaxy. So these two are sitting there within 12 million miles of Earth, 12 million light years, I mean, of Earth. And that's kind of interesting to have them that close. That's our local group in there. Um, the the a lot of science about how galaxies react to changes is being carried out right now using that galaxy. So it's if you've got a moderate sized telescope, it's easy to find off the bowl of Big Dipper, and it gets kind of fascinating because it's, as you can tell from looking at it, it's very bright when you can actually get it in a telescope. That's M82, the cigar galaxy, which is kind of a dull name for something that I think is so interesting. If you look at those, the left and right sides, there is the outer disk of billions and billions of stars around the extreme starburst region near the center.
Yeah, that's one of my favorite edge-on ones to look at as well, or mostly edge-on in up in Ursa Major. Very cool. All right, well, let me show everybody where that is in the night sky. So again, I'm using a free program called Stellarium. And so now we're looking kind of northeast. So here's Ursa Major, the Big Bear or the Big Dipper. Right now, a lot of times the handle is at least for us down here in Tucson is down below the horizon, but this time of night is starting to peak up just barely. But here's the handle of the Big Dipper, and then here's the bucket of the Big Dipper. We call these two end stars pointer stars because they always point to the North Star. So if you can see the bucket, you can see these two end stars, just follow it over and that'll be the North Star. Polaris is in the handle of the Little Dipper and in Ursa Minor, or the Little Bear. And it just curves down here and you can see the bucket down here. Most people can only see Polaris and these two end stars. If you can see all the other stars, and especially I think it's this one is the dimmest one. If you can see that one, you've got really good skies. But if you can see any of the other stars, typically you've got good skies. So Ursa Minor is a good gauge of how your skies are. But going back to what Jim was showing, so again, here's the bucket of the Big Dipper, and this right here, this flashing right here is where M82 was. And I'll zoom in a little bit and you'll be able to see that M81, Bode's galaxy, is just off to its side. So sometimes if you've got really small telescope, you might be able to get both of these, but they're usually far enough apart that you can't quite get both of them in the same field of view. But that is in Ursa Major, the Big Bear. All right, Bernie, over to you.
All right. Oops. There we go. Too many steps. Okay, I was showing galaxies. Now I'm going to jump back to planets again. because planets are my other favorite thing to show. And our planet of the night is, if I can get it to rotate. Okay. Come on. What's going on here?
Well, if it won't rotate for whatever reason, you can just leave it in the vertical.
No, no, I got it. I knew what was going on. I just had to wait for it. All right, so this is the planet Uranus. And Uranus is that big bright blue one right in the middle. Now, if we zoom in a little bit, we'll be able to make out a little more clearly. That is Uranus, the seventh planet in order from the sun. Uranus is a ice giant, what we call the ice giants, Neptune and Uranus. Uranus right now is approximately 2 billion miles from Earth. Now, one thing I've noticed or I've picked up on in recent conversations and out in the public and doing star parties, the public has the wrong impression that Uranus and Neptune and the planets actually give off light. They don't. They reflect light. So what you're seeing is not light from Uranus, not light generated from Uranus, it's light reflected, sunlight reflected by Uranus. Now, 2 billion miles is a long way to reflect some sunlight, but it's a big planet, quite large, much larger than the Earth, and it has an interesting atmosphere. Being as cold as it is, there's very few gases that stay gaseous. Methane is one of them. So methane is a strong or a large constituent of the atmosphere of Uranus. Now, methane gas, being its atmosphere, or a good portion of its atmosphere, methane gas will absorb the green and red and yellow spectrum of sunlight. So the only thing that's left is blue. And that blue is reflected back at the Earth. And that's why Uranus appears bluish when we look at it in a telescope. And Neptune is also bluish because for the same reason. It's strong methane atmosphere. Somebody's got their mic on. According to what I was able to find on the planet Uranus, the temperature at Uranus is 49 degrees Kelvin. It's extremely cold. It's minus 371 degrees Fahrenheit. So it is actually the coldest surface of all the planets. Even Neptune is warmer. Not by much, but just enough. One of the interesting things of Uranus is that it is tilted 90 degrees. Its rotation or axis is tilted 90 degrees. So instead of a top turning with a top and a bottom, like we would think, spinning, its axis is actually pointed at us. and it's spinning around. Hard to describe. Anyway, one of its poles is aimed at us, the other pole the other way, and it's rotating around left to right, if you will. It also rotates backwards. It has retrograde rotation, which is also unique to all of the planets. Let me think. Venus doesn't go backwards, does it?
No,
Yeah, it goes backwards a little bit.
yeah, it rotates very, very slowly.
Its
Yeah,
year is longer
yeah,
than its day.
yeah, yeah. I thought after I said that, I thought, well, wait a minute. No, I think Venus does go backwards. Anyway, uh, uh,
Uranus rolls around on its
yeah,
side.
that's right. That's because it's 90 degrees.
Yep.
So it has a very unusual year. Its year is 84, or it takes 84 years for it to go around the sun. So for half of that rotation, one of its poles is aimed at the Earth, and for the other half of its rotation, the other pole is aimed at the Earth, or aimed at the sun. So it has a very odd rotation period. It would make for a very unusual day, if you will, on Uranus. It has 28 known moons. Now, most of those moons are obviously very small and probably were discovered by the Voyager 2 spacecraft when it went by Uranus back in 1986, if I remember right. Uh, but some of them are large enough to see with a telescope. And if you look closely right around the planet there, you'll see a bunch of little specks, little dots. There's one at about 7:30. There's another one a little further out at 7. There's one up at 12:30, and very possibly the one at 2:30 and at 4:30, 5 o'clock. I believe those are moons of Uranus. The only way to really tell is to look at Uranus over a number of nights and follow the dots and see if they travel along with Uranus or not, because it is hard to differentiate them from background stars. But the close ones in are almost for sure uh, moons of Uranus. Interesting fact on the moons of Uranus, they're named after characters in Shakespearean plays, female characters in Shakespearean plays. So this is the planet Uranus.
Yeah, I always enjoy looking at one of your images of those distant planets, Bernie, because you can pick out some of the moons. Whereas when you're looking visually, it's very, very hard to spot the moons. You need pretty good sized aperture and be able to zoom in quite a bit. But you can, and visually you can easily see the colors, the blue color in both Uranus and Neptune.
Yeah, there's one real close there on at 7:30. I'd very much like to know which one that is. I might check later on and see if I can just differentiate which one's which here.
Yeah, very cool. All right, so let me, guys, we've been going for an hour 15, so we got about 45 minutes left. So probably two, maybe three more objects each.
Okay.
Works for me.
All right, let me show you where we're looking in the night sky. So Uranus is off to the west. It's kind of, here's Venus. We're really just about ready to set down here in Tucson right now. Uranus is quite a bit, quite a bit higher. And then Jupiter, which is also very bright, is up in Taurus, the bull. So when you look, if you were to look pretty much straight up, or maybe a little bit towards the west, you'll see bright Jupiter, and then you'll see the V shape of Taurus's, the bull's nose, and the really reddish one or orangish one that's pretty bright is a star called Aldebaran. But Uranus is just down below that. Uranus is technically right at the limit of naked eye, but it's incredibly hard to see naked eye. You'd have to have really, really dark skies, and then you have to know exactly where you're looking at to be able to see it. You can spot it with binoculars, though. All right, Jim, over to you.
Okay, thanks. Let me go share something here. And this could be one of the easier to guess the name of. So I usually never say what it is and see if whoever I'm talking to with it can figure it out. It's an open cluster in the club of Orion over his head. And that one is the 37 cluster. It's kind of and it jumps out because not many other stars around this little guy. It's an open cluster in Orion, but in the upper part of Orion. So this is another one discovered in 1784 by William Herschel. It's about 3,800, 4,000 light years away from us. With an apparent magnitude of about 5.9, which is just about the limit of being able to pick it up if you're on a mountain somewhere. It only has measured 30 stars that are in this cluster. So if we go back and think about how clusters are formed, clusters are formed out of the same gas cloud, and the interesting thing is the bigger the stars are, or the more of them there are, their mutual gravity tends to keep them from drifting apart so much. But this one is just hanging there with so few stars in it. Clusters usually have hundreds of stars, 100 or more stars, but this one is pretty sparse. But the ones that are left are all hanging around, and the fact of it being so sparse is reflected in its size. Diagonally, it's only 7 light years across. That's very small, but remember, there's so many stars in there, and if you consider we're about 4 million light years away from our nearest star, and 4.5 light years from our nearest star, this got 50 of them in 7 light years. So that's an interesting. We're just happen to be in the right direction. Also, whether you see the 37 depends on the kind of binoculars, or binoculars, you should see it if you got powerful enough ones. In a telescope, it's tricky. And the reason is the number of mirrors in the telescope, because the telescope tends to, if it's got a glass lens in front of it, like an old pirate scope or a refractor, that flips things up and down and left and right at the same time. If you have a telescope like I'm using, it's a different number because it flips off the back and flips again off the secondary mirror, and it comes in the back. And if you use it with an eyepiece, it's got a diagonal that flips it once again. So you tend to get one it's okay left and right, but up and down is flipped. In this case, it's flipped for me because of the way it rotates around the Earth and the way the camera is positioned in the object. But I have software on the camera. I usually show everything I'm working on the side of it, what I use to work with it, just in case people are curious. But I've got this magic little window on it that lets me do some things. And what I did was this little box right up here, it says flip, because as it naturally appears in the sky, if we wait a minute, we might be able to see it like that. But if I flip it back, I can get it like it's supposed to be, like it is in a university or a professional telescope. So that's the 37 cluster, and I wish I could say a lot about it, but it doesn't have a lot to say about it. It's also had the nickname before you could get that much resolution out of the shopping cart cluster, because some people thought that at least the three looked like a shopping cart in their dim optics that they were using.
Okay, I'm not sure I see a shopping cart.
I don't either. I just had to say that. It's like it's hard for me to see a Kachina doll in the owl, but
Right. Yeah, I mean that's always a cool one to look at, just because it's something that we recognize, even though they're just stars and it's open cluster. But some of the open clusters are just beautiful to look at, and this is just interesting because it looks like something we know. All right, let me show you where that is in the night sky. So where we are looking now is towards the south, and it's in up in the by the elbow in Orion. So it's just up above. Here's the belt again. This is the red star, red supergiant Betelgeuse, and it's right up in here. Okay, Bernie, you ready?
Yeah, you caught me off guard there.
All right, you got it.
All right. As I said earlier, I'm switched back over to planets. So we're going to take another planet here. This is another big favorite of the viewing public. As soon as I can bring it up. All right, here we go. Now I'm going to get contact with my scope and we'll be good to go. Come on, talk to me. The Wi-Fi's got a link.
It's tired, Bernie. It's tired.
Well, it could be the battery's getting a little tired. That's true. Come on. There she be. All right, so this is the planet Jupiter. As soon as I can get it to, there we go. Oh, come on. Here we go. Actually, it looks better that way. Okay, this is Jupiter. And the first thing that you obviously see is the cloud belts of Jupiter. There's two major belts. These are called the equatorial belt, the north equatorial belt and the south equatorial belt. There's also smaller, more distant equatorial belt, or not equatorial belts, towards the poles. So if you look below and above the equatorial belts, you'll see additional belts there that are a little fainter, but they're pretty obvious. Jupiter is a gas giant, so it's huge ball of gas. It's questionable whether there's actually has a rocky center. It's more likely that it would have a compressed metal core that may or may not be solid. Being fifth from the sun, it's closer than Uranus was. So Jupiter right now is a half a billion or 500 million miles distant from the sun. It's obviously much, much larger than any of the other planets. And for that reason, it shows up very easily in any kind of telescope. Even the smallest of telescopes can see Jupiter. You'll notice up in the right above it, there's two little dots there. Those are two of the what's called the Galilean satellites or Galilean moons. The Galileo was the first one to, in recorded history, to aim his crude telescope up at Jupiter and actually see the moons of Jupiter orbiting around Jupiter. And he brought it to the attention of the church at the time, and he got in a whole lot of trouble because of it. So these are two of the Galilean moons. The other two are probably outside of the field of view right now. I didn't see them when I was looking a little earlier. They're named Io, Europa, Ganymede, and Callisto. Those Io is a volcanic moon. There's actually erupting volcanoes on Io. Europa, Ganymede, and Callisto are more icy moons. There's a lot of interest right now in Europa because it has geysers of ice sprouting out of it. And that ice gives the distinct impression that there's an underwater ocean underneath the ice. So there's a lot of interest in exploring that under ice ocean of water in the future with spacecraft. You'll notice on one of the bands, the top or the right side band, if you follow it along up towards the top of that band, you'll see a lump. That lump is actually what's called the Great Red Spot. The Great Red Spot, it's not real red in this image, but as it rotates more straight on, it probably will become a little more pinkish to our view. It would take some time for that to happen, though. Jupiter rotates in about 10 hours, so it's a very fast rotator. The Earth takes 24 hours to make one rotation. So you can imagine how fast things are moving along on the surface or the gaseous surface of Jupiter. The Great Red Spot is a vortex hurricane or tornado that's lasted for hundreds of years and probably will continue to go for who knows how much longer. Jupiter takes about 12 years to orbit the sun. So one of the nice things about that is it goes through one constellation just about every year. You can kind of follow it along as it moves through the different constellations of the zodiac. It has 95, 96, 95 or 96 known moons right now. Again, the vast majority of them are very, very small and can only be found with orbiting satellites. So this is Jupiter, the king of the planets.
Very cool. Very nice picture. And I'm glad the red spot cooperated with us tonight.
Yeah, it wasn't out well, it was on the other side last night, but
Yeah.
tonight we got the beginning of it.
Yep. Very cool. Yeah. Jupiter and Saturn are two crowd pleasers in telescopes at any kind of event. And I would, strongly recommend if you have not looked at either one of these through a telescope, it is definitely worth doing or at a star party because they look incredible. I never get tired of looking at them.
No, me neither.
All right, I will show everybody where that's in the night sky. Go. So Jupiter's pretty much straight up, maybe a little bit west now of straight up. If you see Orion and the belt, the belt of Orion, one direction points towards Sirius, the brightest star in the night sky, which is over here in Canis Major. go the other direction, and you're pointed towards Aldebaran in the constellation of Taurus. This is the V of Taurus, and Jupiter is the bright thing right above Taurus, and it's hanging out in the constellation of Taurus right now. All right, Jim, you ready?
Yeah, I think I give you a treat here.
All right.
Seems like we're hanging around Orion a bit this time. Come on, get up there. There it goes.
Orion has so many goodies.
Yeah. Well, when you're looking at something near the center line of the galaxy, you get lots of stars and things. So you find galaxies when you look away from that. Have you got it yet?
Yep, we see it.
Yep, sorry.
Okay. This thing is Messier object number 35. And I got to say something first about what a Messier number is. This was started out as a young man in France, in say around the middle to late 18th century, and he didn't have a whole lot to do at home. The farm was really successful. His father died when he was 11. They had enough hands to run the farm. So his frustrated uncle thought, this guy's got to get a job. So when he was about 20 years old, he got him a job with the French Navy, and his job was titled Chronicler of Dynamic Events and Draftsman. And that meant that he was supposed to be looking at the sky, which he took to be serious. And the reason that the French Navy wanted him to look at the sky is that they were superstitious. And his job was to look particularly specifically for comets. And so he became a great comet hunter. And he did get a high position in society eventually. He got the French Academy of Sciences brought him in as a member. So that meant that the memory of his father was satisfied because he actually had done something worthwhile. But the reason he did that is so people wouldn't confuse what he was looking at with a comet. So his catalog, the forward to his first catalog of his first 40 out of 110 objects, it actually had a forward saying that the reason he's putting this catalog out is so regular astronomers would not confuse these objects with items regarding requiring study. So he thought these were uninteresting objects. Whenever you hear the Messier number, if you look at Messier 42 earlier, the Messier, the Orion Nebula, he thought that was not worth looking at. So I think got one here that's kind of interesting to look at because of the numbers involved. If you take a look at what you're seeing there, the shape of the stars in that, and I've got it on a pretty low exposure. In fact, I might drop it a little bit to try to see why they named it what they named it. Messier number 35 is called a shoe buckle. And that is kind of, so what, of an, you say, and it's really because you consider the time when it was named, and I'm trying to fuss around here on the side with my the number here, and I'm going to drop it down a little bit. And I'm going to go down to 4 seconds, and we should see less stars, perhaps. Okay, that figure in the middle, some people thought it looked like the buckle on Revolutionary War era shoes, the big square buckle. It doesn't look quite like that to me, but what the heck. The facts about it are that it's scattered. It's actually scattered. That image you're seeing in there is almost a full moon size. So it's scattered over quite a big part of the sky annularly. It's 3,870 light years away from us, and its mass around the core is 1,600 suns. And we're looking at something that doesn't look quite that populous. Its size is about 20 light years across, and it's estimated to be about 175 million years old. That's why they're not cluttered in together so much, and they're opening up a little bit. Well, what I'm going to do is expand the the exposure a little bit, and let's see what's really in that little chunk of space. And if you watch the gray bar going along on the bottom of the screen, if your screen shows it, it shows the seconds as they tick off. And so we're up to about 11 seconds now. Let's see what happens when we get out there. And then we'll see what this cluster looks like, the actual population. And it's so bright there, I'm going to have to adjust the histogram a little bit. Okay, but it takes till the end of the 20 to get the sky a little darker. But look at the other population. It was all hanging around there. And that's why they get the size of it being so populated. So there is the scatter of things around the shoe buckle. And that's all part of the same open cluster. So it's about 20 or so light years across. And so they're not too cozy. They're almost 4,000 light years away, though. That's a long way away to see stars. Normally, they're not that far away when you look with their naked eye. And so what you're seeing there now is a better shot at 1,600 stars. Remember, I'm only showing the intersection of it because I can't shrink it down small enough. You can see I've got a lot of margin around there. I shrunk the image as far as I could. And that's M35, the shoe buckle. And it's still in Gemini, but it's close to Orion and Taurus, where we just were.
Yeah, that's an interesting open cluster. And like you said, the open clusters can just look phenomenal in a telescope, especially if you've got dark skies. They almost take on a three-dimensional look to them. I personally did not see the shoe buckle, but hey.
I don't either. Some days it will look more square across the middle like a rectangle and it won't be so pronounced on the up and down. And it almost does look like a shoe buckle. But, one day the other camera I had wasn't working well and it looked perfectly like a shoe buckle. So I've always been trying to show that.
Yeah. Well, and I tell people when we're doing events and whatnot, it can be whatever you want. You can go out in your backyard look at the night sky and make up your own constellations. That's okay. We don't
maybe a picture of a shoe buckle overlaid on top of it would give a better idea. Yeah.
Yeah.
Because
wonder.
I'm trying to envision a shoe buckle here myself.
Yeah.
Or how much mead were they drinking when they named this back in 1780?
Yeah. All right. So Jim, you'll have one more after this, and Bernie, you still got two more.
Yep.
I'm going to share where this one is, and then we'll go to the next one. So this one, as Jim mentioned, is still in the neighborhood of Orion. It's kind of in between Orion and Gemini, down at the foot of one of the Gemini, the twins. So when you look up in the night sky and you see Castor and Pollux up here of the twins, right now most of the views you're going to see, they're going to be looking more sideways. They're going to look more like that. I think is the current view where things are shooting off to the side, and this is the stick figures of Gemini, the twins, and Mars is hanging out right in the middle of Gemini. And then here's Orion and his belt, and then right over here by the foot of one of the twins is where the shoe buckle is. So I guess that's another reason why it could be the shoe buckle. It's on a shoe. Who knows? Okay, Bernie, over to you.
All right. So jumping back and forth between the two of us works out really well. It gives me enough time and I'm sure Jim feels the same way, just enough time to find another object, zoom over to it, and get it presented well. All right, so I'm going to try sharing. Here it comes. All right, all right. Off, on, and reestablish. I think I'm just at the edge of the range of my Wi-Fi over to the scope. So sometimes it's there and sometimes it drops out.
Yeah, that could be why it's a little bit slow then.
There she kicks. All right. So this is called the Flame Nebula. It's also called NGC 2024 or 2024. NGC is the astronomical designation for it. The NGC stands for the New General Catalog. It's a listing of objects in the sky, nebulas, galaxies, anything that's unusual, that's not just a standard star, that was um, created back in the 1800s. And there was something like 10,000 objects in the new general catalog. Anyway, this is 2024 in the new general catalog. It's called the Flame Nebula because to a lot of people, it looks like a flame. Looks like a flame on a Bunsen burner or something like that. That bright star that you see in the lower right, that is the star Alnitek. That star is and Jim will show this to you when he shows you where it is on his map. That star is the furthest left star of the three stars in the belt of Orion. So that's that bright star there, Alnitek. And the Flame Nebula is just off to the left of it. The Flame Nebula is a huge, enormous cloud of hydrogen gas. And let's see if I can find out what it is. It's about 12 light years across from left to right. That's about 12 light years across it. Now, just to give you an idea of size, as Jim mentioned earlier, our closest neighbor uh, star, Proxima Centauri, is just a little over 4 light years away. So this is 12 light years across. It is an enormous cloud of hydrogen gas. And that cloud of gas is creating new stars. There are stars within that cloud that are 1 million years and even younger. So if I zoom in on it, you can see there's a lot of brand new stars embedded into that cloud. Now, the reason it glows is because some of those stars are O-type stars. They're huge, very bright, very powerful generators of visible and ultraviolet light. So those stars are pumping out tremendous amounts of ultraviolet energy into that hydrogen, causing it to ionize and re-emit light in the what's called the alpha wavelength of hydrogen gas, which is around 6,500 angstrom units. It's right in the red spectrum. So that's why it looks like a big red cloud. And the dark section up the middle is actually a foreground section of the cloud that is not emitting light. It's absorbing light and it's blocking the light from behind it. So that's why it looks like a big black cloud. It's actually just more of the hydrogen cloud just absorbing rather than reionizing. The Flame Nebula is approximately 1,300 light years away. And it's part of an even larger cloud of hydrogen gas that's called the Orion molecular cloud. Huge, huge area of hydrogen gas. So a quick look at the Flame Nebula.
And that's a gorgeous image of it too, and it definitely shows the flame. All right, let me show you where that is in the night sky, and then we'll go back and do one more object each and call it a night. So, as Bernie mentioned, we're back in Orion. Orion's been very popular tonight. Here's his belt, and yeah, right where we're at is right next to his leftmost belt star, is where the Flame Nebula is. So down here's his sword. You can start to kind of see the Orion Nebula down here in the sword. Right up here is the Flame Nebula. All right, Jim, you ready for your last one?
In about 15 seconds.
Okay, well, I can.
The Mount lost its brain for the last object, so I'm trying to be gentle with it, but smack it once in a while.
All right, well, you let me know when you're ready. Otherwise, I'll just kind of
Yeah.
talk a bit more about the night sky.
I'm going to do this one in 2 stages, and I've got the first one just about centered, so I'm close.
Okay.
And,
all right, I'm going to stop the share, and you share when you're ready.
I shall. And just have one more thing. And there it is. Much better. Import. Where am I at? 840. Well, I'm ready anytime you are.
Yeah, go ahead.
Okay. Let me get shared first. The application is, it wants to hide the Zoom window. I'm trying to persuade it. Well, I think I got it. Nope, that's not.
Yeah, still
I don't know what's on its little mind. It's not being shared with you, right?
No.
Yet?
Nope. Not yet.
Well, I'm going to minimize mine and see why the heck every time I point to you, it brings me up. Or it brings the thing I want to show up. What are you doing? If it's hiding somewhere here. Oh, I see it.
Your system's tired too.
Well, it's not like it's. Oh, there. It had made you a little postage stamp up in the corner. Okay, let's see if I can do this. Does it give me that? Oh, of course not, because I hit it. See if this works.
Oh, it's starting to come across.
Yeah, but I got Bernie right in the middle. I mean, I got you, Bernie, in the.
Okay, it's coming across fine now.
Okay, you got it in the middle?
Yep.
Okay, this little thing is New General Catalog number 7789. Most of the New General Catalog, which a lot of us astronomers use for that and the Messier catalog, we do that for a lot of the common objects that have been around for a while. They were both, that catalog was developed by William Herschel, objects that William Herschel and his sister Caroline, and later his son John Herschel had discovered. John Herschel moved to South America to do his research while William Herschel was in London. And as was his sister, after she turned 20, she moved from Austria there. But they were doing this fantastic stuff so William Herschel could become a better orchestra conductor. He was a musician. He had first served in the Austrian army And after he had visited England, he liked it so much and left the army to come over and be a musician. So he traveled around for about 20 years and settled in the city of Bath. Now, to be a big city back in that age, they didn't have to have a major league sports town. To be a major league city, they had to have an orchestra. So Bath had an orchestra. Bath, England had an orchestra. And they used him as their musical arranger, his musical director, and it had a conductor. So he was sometimes writing music and sometimes playing recommend they play other people's music. The conductor died. And so William Herschel became one of the first composers back in that era. We look at the 1600s to 18 through the 1800s. In that era, one of the first composers who also was a conductor of his own music. Usually they just throw it under the transom. But somebody told him early on when he was doing this, as he was both the musical director and the conductor, told him that if he polished a mirror, he would see light spots in rings because that's how the energy was stored in the light coming in. So he was trying to make parabolic mirrors for telescopes, little ones, 4, 6, and 8-inch mirrors, to try to see if he could get the rings to give him ideas on how to put chords together and how they were distributed. In his sixth mirror, all the same time he was conducting the Bath Orchestra, he found the planet Uranus that Bernie showed you a bit earlier. That was the sixth mirror he tried. When he brought his sister Caroline over, she turned out to be very, very good in mathematics. And she looked over, told him he was correcting his math and all the star stuff he was doing. And he ended up sending her to Oxford for the greatest mathematical education that was available on the planet at the time. For about 40 years, she was the world's greatest mathematician. And she started building catalogs of her own. She got 1,600 planetary nebulas that she found, and she found 11 comets on her own. Meanwhile, the Herschel family's findings in all their catalogs were put together by an astronomer named Dyer. And that became what he called the New General Catalog. And it's got about 9,000 objects in it. And later on, he made up the index catalog of more objects. And that's got a lot of John Herschel's objects in it. But this was 100 years after the Herschels lived. He put them together. This was her object number 7,789. The object that's sort of in the middle, I might bump the controller a little bit to move it over some, but she thought it looked like a star. So rather than call it Caroline's cluster, and I'm waiting for the next cycle to go on, you see the stars are streaks because I moved them out to try to bring it closer to the center. That's a little better. And one more cycle here. So it's on 10 seconds of grabbing these things. She thought she saw a star, so she called it the Rose. And actually, in the opposite side of the sky, I'm looking up in Cassiopeia right now, in the opposite kind of side of the sky, there's another cluster called Caroline's cluster. She thought it looked like rose petals. Now, I've got a lot more stuff's coming out in it than because I'm going for 10 seconds. She would have gone what would be the equivalent of about 3 or 4 seconds. She thought there were rose petals in there. So it hung around for a long time, and people started doing research on it. Remember, I talked about a couple of 100 million years and clusters fall apart. This one has been aged out as 1.75 billion years old. And you do that by checking the chemistry of the stars and seeing how they've evolved along their lifespan. And unfortunately, what I did was I gave away the secret a little bit. If you notice it, there's a lot of faint stars in the background. They're all part of the same cluster. I'm going to increase this now. And let's see. What I'm going to do is start stacking them. I'm going to stack 2 images, and you can start seeing the regular ones come out. Where it says enable, I'm going to go 2. I'm going to say do it. So it'll take 20 seconds to find the full amount of the first one of its first time through. And after that, it'll hold that constant picture. It'll keep replacing the bottom of the stack. So that should be 1. And I told him to stack it. Let's see how it stacks. a little brighter, and there's more coming out in the background. But what'll happen is the next one should look a lot better, I think, I hope. The big point about it is all the things you see in the middle there are um, that's all one cluster of stars. And it's an open cluster because what would be called a globular cluster is old stars that are the core of an old galaxy that was kind of pulled in. So, well, that was Caroline's cluster, and she thought it was important and to write about it. And it turned out she was right. Those all were that all those stars in that middle ball in there is one cluster. And she only saw the faint ones that made it look like rose petals hanging out there. That's New General Catalog 7789, Caroline's cluster, and that one again is in Cassiopeia.
Excellent. Yeah, that's a gorgeous view you got there. You can see lots and lots of stars in that cluster.
Yeah, when I do it with the 4 seconds and then double stack it, you can really get that magnification a lot better. But I was, like I said, the mount lost its mind. It was pointing me in the wrong spot. So, but that is a beautiful cluster of stars, and it's 1.75 billion years old. And if you ever study this stuff for real and you start looking for the nomenclature, that would be written as one GYO. That's giga. Or in an astronomical sense, you put a G for billion.
Hmm. Yep. All right. Well, excellent. So yeah, that where that is in the night sky is right near Cassiopeia. I get the right one? Yeah. Okay, Bernie, let's do your last one, and then we'll give you guys a chance to make a couple of closing comments.
Okay, yeah, we can squeeze one more in here. Let's see here. Okay. Start to share. All right. I'll wait for a link up here.
Phoning home.
Yeah, when I switch over to Zoom to uh, activate Zoom, it drops out the program, so I have to get it to link back up again each time.
Mine's doing the same thing. I've had a hunt for the Zoom
There it
session
is.
the last
Yeah,
3 times.
there it linked up.
Yay! Woo,
right.
Nice. That is
Oh,
tasty.
what we have here is what's called the Crab Nebula. A lot of people ask me, where did it get the name? I have no idea. Jim probably has a long story on that one, but it's called the Crab Nebula for one reason or another. It's also known as M1 or Messier number 1. The Messier catalog, I don't know if we talked about the Messier catalog at all, but in brief,
Jim did.
Sorry?
Jim did earlier.
Okay. So Messier back in 1780s, 1790s created this catalog, and this is number 1 on his catalog of objects that are not comets. And most of his objects were nebulas of one sort or another, or galaxies, which back then were called nebulas anyway. But this is actually a nebula. And the reason it's a nebula is because it is a cloud of gas, and it is within our Milky Way galaxy. So it's not anywhere near as distant as the galaxies are. It is approximately 6,500 light years away, which is a considerable distance, but well within the Milky Way galaxy. This cloud is right now approximately 11 light years wide. So you're looking at 11 light years from left to right there. Pretty substantial cloud. And what this nebula is what I'm sorry, is called a supernova remnant. So this was or is what's left over from a star going supernova. If we zoom in, we can tell that it is a cloud that is not uniform. It has different sections in it, but kind of dead center. And you cannot see it in this image because I don't have the, uh, the capability of resolving down to the actual star itself. But this cloud is expanding at about 1,500 kilometers per second. So an enormous expansion rate that this cloud is going through. It's 1,000 years old. So it was actually happened in 1054, the year 1054. I remember it well. Jim, you're probably old enough to remember it too.
Took pictures.
You took, yeah, exactly. The Chinese actually registered this in their chronicles as a new star that occurred in the night sky, and it was, I'm sure, bright enough to be seen in the daytime sky as well. And I'm sure it lasted for many weeks and possibly even months. But the supernova created an enormous explosion, and what we're looking at is the expansion of that explosion out into space. This is in the constellation Taurus, and it's fairly easy to spot with a moderate telescope. It was discovered by an English astronomer back in the 1731. Now, there's actually a star at the center of this. The supernova, when it occurred, collapsed down. The core of it collapsed down into what's called a neutron star. And that neutron star is spinning at a very high rate of speed. And it's also acting like a great big flashlight. Sometimes its spin, what would you call it? The spin pole aims at the Earth and causes a short flash of light that we see as what's called a pulsar. So this was the first discovered pulsar in the universe, and it's called M1, the Crab pulsar, and that can be seen actually in the center of the nebula. If you have the right instrumentation, you can see that pulsar flashing on and off, or record it flashing on and off. Very interesting object. M1 Crab Nebula.
Yeah, this is one I love to show at astronomy events, especially if you have a decent dark sky, because it's just really cool to look at. And the fact that it's been around for 1,000 years, almost 1,000 years.
Yeah, absolutely. Okay, I think that wraps it up for my objects.
Yeah, so let me come over and check something here. change the share over here and we'll wrap things up. So I will actually just turn it over. Jim, why don't you go first and just a few closing comments, and then Bernie, and then I'll close us out.
Well, it was great to be able to get out and do this. This is the longest I've been able to get together and do astronomy for the last couple of years, and it felt good to get out and do it again. And it was not intentional to show objects only in the Gemini and pretty much Gemini and Orion area, although I did pop over to Cassiopeia for a couple. But they were just very interesting things to look at, and it just was fun to work with them. I appreciate everybody who chose to drop in for us to see us, and I hope this inspires them to keep looking up, protect the night sky.
Okay, Bernie.
Yeah, thank you everyone for coming this evening and spending a couple hours with us. We really enjoy doing this, and I'm sure that if you ever get the chance to come to Tucson, if you're outside of the state, plan a trip here, look us up. We're online at Tucson Astronomy, and we have public star parties, numerous of them every month. We handle probably, between Jim and I, we probably handle over 20 to 25 star parties a month. So lots of opportunities for people who come to visit. And we love the skies here, as you could tell by our objects. And by the way, we aren't just showing you pictures that we pulled out of catalogs or had in our storage vault. These are live images of tonight's sky, so you can tell that the sky here is just phenomenal, and one of the reasons why we love living in the Tucson area. So thanks for coming and spending some time with us.
All right, yeah, and I'll just echo what Bernie and Jim said, and appreciate everybody coming. We do enjoy doing this, and definitely come visit us in Tucson if you ever get down this way. And our next virtual star party right now we're planning for November 14th. If you want to put it on your calendar, and we'll be streaming that over to YouTube again, just like we did this one. So we appreciate everybody coming, and we'll see you next time. Thanks. And think clear skies.